So today we're doing our part of our reasons review, and we're going to start talking about quadratics. We're on question number 15. 15 has 4 parts to it. The first part is we're going to have to sketch this graph. What's a really easy way to sketch a graph? Yeah, we're going to put it in the calculator. Put it in the calculator. How do you say that in Spanish? Yes, poner en la calculadora. So put it in the calculator. Guys, so here's what I did. I put it in the calculator, right? I put it in, and now what do I hit? Give me a button. Oh yeah, hit that graph button. Now I want you to notice something, right? There's a picture. We just have to sketch that picture. That's all it asks for. Just a sketch. When it says the word sketch, here's what you need to put down for this class. And this is really specific. I need you to draw me what you see in the calculator. Don't worry about accuracy, but the things that you have to worry about are you need to label the axes, and you need to put down, like, on your calculator, if you have 10 markers, you need to put down 10 markers over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's what we do, and now we're just going to draw in the sketch of our picture. Like, don't worry about it being too accurate. You're just trying to sketch it in. Just try the best that you can. So we're going to draw it in, and it's going to look like that, and then it's going to do this. And for a sketch, that's good enough. That's good enough. Except that we need one more added thing in here. You have to write down the window that you're using. So we need to write down everything in here except for the X resolution. So let's write that down. Okay. So drawing a sketch is all about a few important things. It's about labeling our axes. It's about drawing in a relatively good picture. And most importantly, it's about putting in our window. Don't forget about anything else on there. Okay. The next thing that you have to do is, now we're going to give you a little bit more information in case you want to be like the most amazing person ever on the face of the earth. This is a parabola, and so technically for a parabola, you should always be graphing the following. What's the middle of the parabola called? What's this point down over here called? Oh, you are amazing! Yes, it's called the vertex. Vertex, yep. Thanks, Ms. Russell, for that. She did a great job. That thing right there is called the vertex, and so we're going to plot that down. You know what the vertex is also called? Point. Called the turning point. Oh, turning point. Guess why it's called a turning point? It turns around. Thank you. It's called a turning point. So when you're graphing a parabola, you should always be graphing the vertex, and then 3 points to the right of the vertex, and 3 points to the left. 3 points. Yep. 3 points to the right, 3 points to the left. And here we go. We're going to try and find that using our calculator. We're going to use our calculadoras. And we're going to go into our table of values. And so here's what you do, right? You go into your table of values, and you go looking for a pattern. Does anybody here see a pattern?
Yeah, I see a pattern.
What's that pattern?
Whoa, it's that means that it's negative 1 to 3.
I see numbers. I see numbers. And so here's what we're going to do. Check it out. The pattern flips over this point, right? Guess what that point is right there? The vertex. It's also called the mirror, the reflection point, because here it is, the graph was coming down, coming down, coming down. It hits the vertex, coming up, coming up, coming up. Got it?
Yeah.
Okay, so now let's fill out our... What's up? So now, somebody help me fill out our screen here so that everybody can see. Give me 3 points that are to the left of the vertex. What's the top one? Negative 2, comma 27. What's negative 1 at? What's 0 at? 0 is at negative 5. What's the turning point? 1, negative 9. And what's the 3 points to the right of it? 2, negative 5. 2, comma, negative 5. What else? 7. What else? 427. You're the man, Henry. The man. Don't let anybody else tell you otherwise. Okay. Guys, So we're back up on the, let me go back up on the big screen. Do you mind if I go back up on the big screen?
Yeah.
Actually, some people can't see, so let me just show you. The axis of symmetry, this is old school, right? The axis of symmetry divides the graph in half, like a samurai sword, right? Like a samurai sword. The axis of symmetry, as it's called, the AOS, this is going to be the axis of symmetry. So the AOS is a line, the vertex is a point. Yeah, let's write that down. And the axis of symmetry is a line. Remember that. So the AOS is the x-coordinate of the vertex. The x-coordinate of the vertex. So what is the axis of symmetry in this particular case? Yeah, the AOS is x equals 1. And that's because vertical lines that go up and down are always just x equals. You good? Okay. There is another way to form the axis of symmetry, and that's algebraic, and there's a formula for that. Guys, the axis of symmetry is also created by an equation. Let me show you. What was the original problem that I gave you? Minus 8x minus what? Okay. Now let me show you that you probably forgot this because everybody does. This first number is a. This second number with the symbol in front of it is b. And this last number right here is c. And so then all you have to do is just plug these bad boys in. Right? So this is really just negative 8 over 2 times 4. And so that's 8 over 8. And what's 8 divided by 8? Look at that. Check it out. I got the same answer. Got the same answer. Woo! That's amazing. So this we solved by graphically. Here we solved it algebraically. You would have to use this if it said specifically in the question, find the axis of symmetry algebraically. Let me put that up. Got some great questions going on. People are saying, like, where the hell did you get this, right? This is a formula. You just got to remember it. Good question. Good question. Let's do part C. What does it ask for part C? Man, what are the coordinates of the turning point? Give me another word for the turning point. The vertex.
It's 1 something.
1, comma, negative 9.
Wait, is it always going to be the x value for the vertex?
In the last part of our problem today, it asks for what are the zeros of this function. What the hell are they talking about? What are they talking about? Let me show you a picture real quick. Here's a picture, a rough sketch of what it is that we got going on here. I'm going to highlight 2 things. You see that right there and that right there? What's a real fancy word for that? The roots. This is going to be super important for next week. Those are called the roots. You know, every time I hear that word, I always think of this song. The roots. The roots. The roots are on fire. Oh, my bad. Okay, guess what these are also called?
No, I know this.
Oh my God. These are also the zeros of the function.
What's that?
Oh, God, the computer is being so slow.
I know, my friend, this class is such a
So dumb. Okay, zeros of the function because, why is it? The zero of the function because it's where? Where 4x minus 8x minus 5 equals 0. We good? Now there are two ways. Now there's a bunch of different ways that we're going to learn how to find those roots, aka the zeros of the function. Right now we only know two ways, but next week we're going to learn two more. Right now we only know how to use our calculator, and if we can't use our calculator, what do we have to do? We got to factor and solve it like we've been doing. Okay? Let's try and use our calculator real quickly. Okay? So, we're looking through our table of value, and we're going to look for where y is 0, because you see y was replaced by a 0. Do you see any places where y is 0?
No.
No! So guess what we are? We're screwed. Means we have to factor. We have no choice. So, can't use the calculator. We're going to have to find the zeros by factor. Oh boy. Okay, so we're going to solve this by factoring. What method are we going to use?
AC.
You're amazing. Yep, we got to use the AC method. AC method.
But is that only if we have 4 things?
No, that's factored by grouping if we have 4 things. AC method, what's 4x squared minus times negative 5?
Negative 20.
Negative 20x squared. We're going to give me two numbers and multiply to be negative 20, but add to be negative 8. Go.
2x, negative 20.
Very nice. Yeah, so negative 10x, positive 2x. We're going to sub them in. Right? And now you have a 4-term thing, Jason. How do you solve it? How do you factor a 4-term thing? Factor by what? Factor by grouping. Crazy, out of control. Two things. Give me what's the greatest common factor of 4x squared minus 10x? Oh my God, you guys are so smart. So smart. What's the greatest common factor of 2x and negative 5? Just 1. Because that's all that goes into them. Oh, this is getting out of hand, right? Getting out of hand. Now we bring these two together, we get 2x plus 1 in one parenthesis, and we got 2x minus 5 in the other. Uh-oh. Out of control, out of control. You know what we do from here? We got to solve these. Oh my God. Oh my God, right? So much work. So much work. What do you say if something is a lot of work? OD, son, right? That's what you guys say. I say this is amazing. Look at the kind of stuff that we're solving. Look at this. This is crazy. Oh, check it out. X equals negative 1/2. That's one of them. Let's solve this one. Let's solve this one in under a minute. Solve this one. We got 2x equals 5. We got to divide both sides by 2. Divide both sides by 2. Whoops. This crosses out. Turns out x equals 5 divided by 2. Oh, there's the other 0. What's 5 divided by 2 in the decimal? 2.5. Amazing. Oh my God. Just admire.
Oh
Just
my
admire.
God.